As you saw in the previous lecture, the compiler will compile your source file as long as individual items called translation units. So the compiler will determine the objects and variables you declare and the types and functions you define. So, and once declared, you can use any of these in the subsequent code with the scope of the declaration. So, at its very broad set, you can declare an item at the global scope by declaring it in a header file. So that will be used by all of the source files in your project. If you do not use a namespace, it is often wise when you use such global variables to name them as being part of the global namespace. So now I want to create a new header file here in C++, which I will explain later what this header file is. So version here, let's create a version header file. And as you can see here, the CLion compiler automatically created the version.c++ file as well. So let's change my username to our Online Computer Science Academy auxiliary name. And here we have a main.c++ file and version file, and also we have a header file of this version CPP file. So in version header file, let's add the extern integer version here, and I will explain all of this code later as I do. And version in C versions.cpp file include the version H file. As you can see here, it's actually included by automatically, so we don't need to write here. And version here equals 17. As you can see, we got a problem here because we have the insert class here. So integer version, integer version return 0 here. Actually we need to main here, and then we will assign version as 770 here. So let's use the main.cpp here as well. Here we're gonna add the print. We're gonna add print function in this main.cpp file. So we have to include the firstly we need to include the version here, version.header file. As you can see here, it comes automatically, and then let's define the print function here, void print version here, and let's use the braces here, std, or actually let's use the printf function here instead of std, printf. Okay, so version is equals to d decimal, because we will get decimal here, and then here version. As you can see, we use this double dots here, as you can see here, because we included version.header file, and in version.header file we have an extern integer version variable, which I will explain what these are. So the code here, as you see here, has two source files: the version CPP and main.cpp here. And we have we have a header file, as you know. Also we have a header file included by both source files here. As you can see here in version.cpp, it's included version header file, and also in main.cpp we have the included version.h file here. So so here the header file declares the global variable version, which can be used by both source files. So it declares the variable but does not define it here. As you can see, we defined it here. We defined version as 17. So the actual variable is defined and initialized, as you can see here. So it is here that the compiler will allocate memory for the variable. So the extern keyword here used on the declaration in the header indicates to the compiler that the version has external linkage. So let me write it. So when you download this code, you will see and read this and remind this. The extern here means external linkage here, and that is the name is visible in files other than where the variables is defined. So the version variable is used in the main.cpp source file. So in this file, the scope resolution operator here, this is the scope resolution operator. As you can see, this is a 2 double dots here, is used without a namespace name. As you can see, in previous lecture, we actually used some namespace. For example, we did, for example, revolver, and then we use this scope resolution operator here. So actually, let me write this scope resolution operator. This means scope resolution operator, and I want to also note this extern terminology. So actually, this terminology matters because you will use them a lot if you do the object-oriented programming or just any C++ programming. You will use this external linkage and scope resolution operator. So of course there's a programs, the simple programs that don't use these operators here or keywords. So you can also declare items that will only be used within the current translation unit by declaring them within the source file before they are used. So usually here top on the file. So this produces a level of modularity and allows you to hide implementation details from code in other source files. So for example, let's write our header file here. Actually, let's create a main here. So auxiliary, and let's in main.header file here we will declare the void usage here, usage function, just a function. We will not write a code in it yet. And in here main.cpp, we're going to include the version h as we did earlier, and then we will use this standard we will use string from the standard library, string application name here, for example, application name, for example, port scanner. And here we have an app name variable string called app name here, which is, this is a string, and inside the string we have a port scanner string here. So as you know, in C++, strings, actually in a lot of language, strings is just arrays of characters here, which you will learn about these strings later also. So then let's use our print. As you can see, we have a print function here, and we will define usage function here also. Actually, let's include our main.include our include main header file here, and define usage, void usage here, and std cout application name here. Actually, we have to define out of this main function here application name, and then here, and then we will call the print function here, print function, print version here. And so the the main .header file here contains the interface for the code in the main.cpp file. As you can see, we use this usage. So only those functions declared in the header file will be callable by the other source files. So the caller does not need to know about the implementation of the usage function. So, and as you can see here, it's implemented using a call to a function called print version. So that is only available to a main.c++ file. So the variable application name is declared at the file scope. So it will only accessible to code in main.cpp. So if another source file declares a variable at file scope that is called application name, and is also standard string here. So this is the string here, as you can see here. The file will compile, but the linker will complain when it tries to link the object files. So the reason is that linker will see the same variable defined in two places, and it will not know which one to use. So a function also defines a scope. Variables defined within a function can only be accessed through the name. So the parameters of the function are also included as a variable within the function. So when you declare the variables, you have to use different names. So if a parameter is not marked as a constant, here, constant keyword, as you remember, if your parameter is not marked as constant, then you can alter the value of the parameter in your function. So you can declare the variables anywhere within a function as long as you declare them before you use them. Here, curly braces are used to define the code blocks, and they also define local scope. So if you declare a variable within the code block, then you can only use it there. So this means that you can declare variables within the same name outside of the code blocks, and the compiler will use the variable closest to the scope it is accessed. So before finishing this lecture, it's important to mention one aspect of the C++ storage class. Here, a variable declared in function means that the compiler will allocate memory for the variable on the stack frame created for the function. So when the function finishes, the stack frame is torn down and memory is recycled here. So this means that after a function returns, the values in any local variables are lost completely. So when the function is called again, the variable is created anew and initialized again. Also, in this lecture, I want to talk about in this lecture, I want to talk about the C++ static keyword. So, but in C++ here, static keyword changes this behavior. So the static keyword means that the variables is allocated when the program starts, just like variables declared at a global scope. So applying static to a variable declared in a function means that the variable has internal linkage. So that is, the compiler restricts access to the variable to that function. So now I want to create an example code here. For example, before this main function, integer increment here, increment, and then let's create a static integer value increment by 1, increment by 1 by 1 here, and return value. Here, let's use the let's print our function here, increment here and d. So increment here, we will use, as you can see, this is the increment. So we're gonna pass one number as a parameter, for example 5 here, or let's create an this function type, lots of types, for example 5 9 19 999. So let's compile this application. Actually, let's create this application here, project as a new project, because I don't want to mess these codes, because I want to share it with you as a file here. And we're gonna write the increment function here, integer increment, integer e here, and static integer value plus equals e here, and we will return the value here. So why we have a, yeah, we have to add here. So then let's compile our code. Actually, let's add new lines here, because here new lines. So by default here, the compiler will initialize a static variable to 0. So, but you can provide an initialization value, and this will be used when the variable at first allocated. So when this program starts, the value variable will be initialized to 0 before the main function called. So the first time the increment function is called, the value variable incremented to 10. No, to 5 here, which is returned by the function and printed to the console. And when the increment function returns, the value variable is retained, so that when the increment function is called again, the value variable incremented by 9 here, as you can see, 5 plus 9 equals 14. Actually, let's create a calculator. So let's create an example without static. Here, this is a static and this is not static here. So, and now I wanna notepad here with static here, or without static, and with static here. And let's add static keyword and start it again. As you can see here, we got a different result. So here, so without static, our value here errs itself and just does nothing. But here, by default, the compiler will initialize the static variable to 0, but you can provide an initialization value here. So, and this will be used when the variable is first located. So when this program starts, the value variable will be initialized to 0 and is incremented to 5, which is returned by the function and printed to the console here. So when the inc function returns the value, variable is returned. So that when the inc function is called again, the value variable is incremented by 5, by 9, and total number is gonna be 5 plus 9 equals 14. So it might be confusing at first, but I promise you will learn this constant and static variables and keywords in later lectures. This is just the beginning of the C++, but I know, and you can do it. So in next lecture, we will talk about the operators, and I'm waiting you in next lecture. So I know this lecture is actually almost 20 minutes. So I hope you watched all of this, and I'm waiting you in next lecture. This is just the beginning or intermediate C++ programming. So after watching and including your my lectures in your practically, you will learn about the C++ a lot. So I'm waiting you in next lecture.